All right, math students, homeschoolers, anybody else who is going through the California Go math, what I'm doing is I'm doing this either this textbook or it's actually both. It's the same page, same content from both, but the key is we're talking about grade 7 right here, and we're doing the independent practice. So let's get started. So what we got is for use a table right here, this table over here off to the side, which looks like I'm going to have to zoom out a little bit and write the ratio in the form of a over b. Then as a decimal, tell whether the decimal is terminating or repeating. All right, basketball players to football players. So basketball is 5, football is 11, so it's 5 over 11. I'll do it in red. 5 over 11. And if you were to put that in a calculator, that is 0.454545. It just keeps on going, so that's repeating decimal. And yeah, I won't show you that. It's just 5 divided by 11. And usually, when you divide by 11, it's going to be repeating. When you have the other one, hockey players to lacrosse players. So hockey is 6 and lacrosse is 10. So that's 6 over 10. Hey, that's 6 tenths. And if you write, you can just write that as 0.6, because 6 is in the tenths place right there. Pretty easy. And since it comes to an ending point, that is terminating. Polo players to football players. So polo is 4 and football is 11. 4 over 11. And 4 over 11, like I said, that's usually repeating. So 0.3636. And you could put a bar over the 3 and the 6, as it's 363636. And that's repeating. Lacrosse players, let's see what we got here. So we have lacrosse is 10 and rugby is 15. So it's 10 out of 15. I know that that's equal to 2 over 3 because I can simplify that. And divided by 3, that's 2/3 is 0.6 repeating. Put it in a calculator. 2 divided by 3, you'll see. And that is repeating. Football players to soccer players. Football I see is 11 and soccer players is also 11. So that's equal to 1. So that's terminating. Nothing repeating there. Okay. So let's look for a pattern here. Beth said that the ratio of the number of players in any sport to the number of players in a lacrosse team must always be a terminating decimal. Do you agree or disagree? So I said, yeah, I agree. Anytime you're going to divide by 10, you're just going to move the decimal, and then, so that means you're always going to have a terminating decimal. You're just going to move it over one time. Nothing's going to repeat. There you go. Because right here, when you divide by the lacrosse players, you're always dividing by 10. Okay, moving on. The change in the water level at the lake was negative 4 and 7/8 inches. What is this as an improper fraction? Well, let's see. You multiply 8 times 4, which is 32, and then you add 7, which I believe is 39. 39 over 8, negative 39 over 8. And what is that written as a decimal? Well, I would write this as negative. I would first start off with negative 4 right there. And then 7/8. The 7 divided by 8 is 0.875. So there you go. In the water level at the If the water level at the lake continued to change at the same rate for 3 months in a row, explain how you would estimate the total change in the water level at the end of the third month. All right, so here you go. 0.875 is close to 1. You know, that part is kind of close to 1. So you can estimate the water level will drop by about 5 inches per month. So the total change would be about 3 times negative 5, which is negative 15 inches. All right, let's see what else we got here. So the vocabulary rational number can be written as a ratio of one integer to another and can be represented by a repeating or terminating decimal. In problem solving, Marcus is 5 and 7/24 feet tall. Ben is 5 and 5/16 feet tall. Which of the two boys is taller? Well, they both got 5 going for them. Okay, they both got 5. That's kind of good. So really, we need to compare 7/24 to 5/16. Well, I think I'll just do the 7 divided by 24 and 5 divided by 16. I'll do it on a calculator. All right, so there you go. I figured out the 7 divided by 24 in a calculator gave me 29.16, and 5 divided by 16 gave me 0.3125. And this is bigger than this, which is what this symbol's saying. So we're saying that Ben is taller because 5.3125 is bigger than 5.2916. So you really just have to compare the bottom part because the 5s are the same. It's the rest of the decimal that you have to worry about. Next, 28. If one store is selling 3/4 of a bushel of apples for $9 and another store is selling 2/3 of a bushel of apples for $9, which store has the better deal? Explain your answer. Well, let's see. So 3/4, and changing that into a decimal, and changing 2/3 into a decimal, we can now compare the two decimals. Pretty easy. 75 is bigger than 66. So the first store is offering the better deal because they are charging the same amount and offering more apples. So they're both charging $9, but they're giving you 0.75 of a bushel of apples, and they're offering only 0.66 of a bushel of apples. Okay, our hot questions here. You are given a fraction in simplest form. The numerator is not 0. When you write the fraction as a decimal, is it a repeating decimal? Which numbers from 1 to 10 would be the denominator? So that denominator would be 3, 6, 7, or 9. If you divide by 3, you're going to get a repeating decimal. Unless you're dividing by like 12 divided by 3. Because, well, you're not going to, huh? Well, anyway, yeah, unless you're dividing by a multiple of 3 or multiple of 6 or multiple of 7 or multiple of 9. But if you're dividing by any of these numbers, you will get a repeating decimal. So Julie got 21 of the 23 questions on her math test correct. She got 29 of 32 questions on her science test correct. Which test did she get a higher score? Can you compare these fractions? 21 out of 23 by comparing 29, 21? No. Not at all. How can Julie compare her scores? So what we got here is, well, the higher score was math. And so what did she get the higher score on? Because if you take 21 divided by 23, that's going to be a better ratio. It's going to be a higher decimal than 29 divided by 32. And you can only compare the numerators if the denominators are the same. So the denominators were not the same. So you can't compare them that way. You have to compare them vertically. Okay. Look for a pattern. If the pattern continues, is this a repeating decimal? Let's see. What is that pattern? You have 1 1 and then 2 1s and then 3 1s. Is this a repeating decimal? I say no. There is a pattern, but the pattern doesn't repeat itself. And that's what I got for you there. I'm hoping this has been helpful for you. Be sure to look out for the other videos. We got the whole book mapped out. Thanks for watching.